in our case, we have created a completely indigenous computing architecture for this. Now, if just to explain that computing architecture part, now in your laptops, you have i5, i7. Those are all Intel's computing architectures for data. The same way for a autopilot of a drone, you need your computing architecture. So our patent is on for the computing architecture of the drone. Now that computing architecture is called distributed parallel control computing. And the reason it's called distributed parallel controlling computing is when a drone operates, it operates in it has two different inputs that come from sensors. One is something which requires immediate action to keep the stability. The second is something which requires, thought out action. So it is something similar to a biomimicry of the human brain, where when we go, say you're going from here to the airport and you're driving a vehicle, suddenly something comes across the road, you take evasive action. You don't think too much. But at the same time, you don't stop thinking that you have to go to the airport. You do both these things in parallel. So the same thing has to happen on the drone if you want to control it. And that is what is our key USP and our key patent about.
So this is something very interesting. And let me also ask you about the GPS denied environment as far as this thing is. So how different is this game? Because EW is the next main game. If you can saturate the air, if you can saturate the waves, you can actually hold the enemy in attack and of course protect yourself as well. So how does your drone gain an edge over that, sir?
See, at the end of the day, now whether, GPS is a sensor. It is a sensor that is giving you locational awareness.